Question 7. Let's see what we've got. Mr. Hawkins was running at 5 meters per second when he slammed into a brick wall and stopped in 0.03 seconds. What was his acceleration during that time? So we're actually going to use that same equation that we just finished using, our acceleration definition. And algebra-wise, this question is a little bit more straightforward because we don't need to change anything about our equation. The tricky part is just figuring out what our givens are. So let's start. It says Mr. Hawkins was running at 5 meters per second. That makes our initial velocity 5 meters per second. The change in time is also pretty straightforward. We can see we've got 0.03 seconds, but there aren't any other numbers. So we have to make some assumptions about our final velocity. If I were to run into a brick wall and stop, that means my final velocity is going to be 0. I'm stopped. I'm not going anywhere. So our final velocity is 0. Now plug all that into our equation. We have 0, important to write that one first, minus 5 over 0.03. And then see what we get. Looks like we'll end up with a negative 166.67 meters per second squared. Some important things about this. First, those units. Don't forget the square here. And this negative, that makes sense since I was traveling at some velocity, then I stopped. Finally, you might be surprised that it's such a big number, but keep in mind, I stopped really, really fast. So for something to stop so quickly, it needs a very strong acceleration. So that all checks out, and we are done.